In this video, I am going to explain you how the MUL instruction will be executed. So MUL and source that is given in that instruction. So whenever we are using that MUL instruction, this instruction is used for multiplication of two registers. So here we have to check if the source is byte or it is word. If it is a byte, then it is 8-bit register. And if it is a word, then it is a 16-bit register. So we have to check either it is a 8-bit or 16-bit. So depending on the size of our source register, our operation will be decided. If the source is byte, that is 8-bit, then we are performing the operation like AX is equal to AL into unsigned 8-bit source. So here the first example is MUL 30H. So whenever I am writing here MUL 30H, then value of AL will be 30H. Then we have written MUL 60H. So our contents of 60 will be copied into our BL register and our BL becomes 60H. And after copying the values of 30 and 60 into AL and BL register, we are performing the multiplication of this BL register. So whenever we have to perform the multiplication of our register, that time we are writing here the source register and our source register is BL register. And whenever we are checking here the 16-bit and 8-bit register, that time our BL register is a 8-bit register. So whenever your operation is in 8-bit register, that time we are performing here AX is equal to AL into unsigned 8-bit source. So here in this example, our source is BL register because we have written here MUL, then our source that is BL. So what are the contents of our AL and BL register? Our AL is equal to 30H and our BL is equal to 60H. So 30 into 60, it will become 1800H. So this is the value that we got from our calculation 30 into 60 and the contents will be stored in our AX register. So how the data will be stored into AX register? Our contents of AH will be 18H and the contents of our AL will be 1000H. So these are the values that are stored after performing the multiplication of this 30 into 60. So this is the structure that is given in our register structure in our programmer model. Here is your AH register and it is our AL register. And this becomes AX register. So the contents of our AH will be 18 and the contents of our AL will be 00. So after performing the multiplication, the result will be AX is equal to 1800H. So here we have performed the operation with our 8-bit number. That is our 8-bit register. Now the second example is MOV AX, 3000H and MOV BX, 1000H. So after performing this operation, how we are performing the result and how the values will be stored. So check here, our value of AX will be 3000H. So your AX will be 3000H and our value of BX will be 1000H because we are performing this MOV instruction. So whenever we are performing this MOV instruction, the values of our source will be copied into our destination register. And here our destination is AX. So our AX value become 3000H. And our value of BX will be 1000 will be copied into our BX register. That is our destination register. So our BX become 1000H. Now whenever we are performing the multiplication of our BX, that is our BX is 16-bit unsigned source. So this is the 16-bit unsigned source and whenever we have to perform the operation with our source, and if it is a word, that is our 16-bit data. That time we are performing the multiplication and our result will be stored as dx colon ax equal to ax into unsigned 16-bit source. So I'm writing here dx colon ax is equal to ax into unsigned 16-bit source. And here our unsigned 16-bit source is BX register. So I'm writing here AX into BX. So the value of our AX is 3000 into we are performing the multiplication with our 1000. So after multiplication, it will become 3000, then this 00 and 0. So this is the result, and how this result will be stored? This will be stored as dx colon ax. So it will become a 32-bit of our data. So we are appending here 0, and this 4 bits will be stored in our dx register, and these 4 bits will be stored in our ax register. So the contents of our dx will be 0300H, and the contents of our AX will be 0000H. So these are the value that we got from our multiplication result. So the first of all, we are copying here the contents of AX and BX, that is 3000 and 1000 H. And after performing this multiplication BX instruction, our result will be stored as DX colon BX. So the first lower byte of our data, that is lower nibble, will be stored in our AX register, and the higher nibble will be stored in our DX register. So 16 and 16, it will become a 32-bit of our data after performing the 16-bit of our multiplication instruction. So in case of multiplication instruction, what we have to check whenever the example will be given, that time we are checking if the source is byte or if the source is word. If it is 8-bit, then your result will be stored in our AX register, and if it is a 16-bit, then our result will be stored into our DX colon AX register. So this difference you have to remember whenever you are writing this instruction, that is MUL then source. Whenever the question can be asked in the exam, that time you have to write the operation that are performing in that MUL instruction. Then with the help of example, you have to write down all the contents that are changed in our register structure. So in this way, our multiplication instruction will be executed.